Okay. So last time we talked about Docker, and we got Docker set up. Today we want to talk about databases and Docker Compose so we can get our full functionality. So right from homework 1, we need a database that we can connect to be able to communicate. When we get to objectives 4 and 5, those are going to require a database, and we're going to use Docker Compose to set up that database. So let's learn how to do that. So first, database, I would assume you're all, or at least most of you are familiar with the concept of a database, but I'll just very briefly go over, just in case, or at least to refresh your memory. So a database is a way to save our data on disk, so we're not messing around with file I/O, how to represent our data, and how to retrieve that data. It's going to take care of all the low-level details for us, so we're not thinking about the format of saving our data. We don't want to save our data in like a text file or any of that stuff. We tell the database, hey, store this data, and then we can retrieve it. Hey, database, give me that data when I want it. And then the database is going to mess with the low-level stuff, actually saving that data to files, saving it to disk, doing all that stuff. Very nice utility that we use extensively in programming. We're going to look at two different types of database, MySQL and MongoDB. I'll tell you right up front for this course, I recommend MongoDB. It's just a few fewer headaches, especially with the setup. MySQL has some issues, has some potential issues playing well with Docker and Docker Compose that you just avoid when you use MongoDB. So for that reason, in this course, I'll recommend it. To make your life a little easier, we're here to learn about web apps, not debugging a database inside Docker. So MySQL is a structured database, and MongoDB is a very unstructured database. And I want to talk about what each one of those is in a little bit more detail. So each one of them is going to be a TCP server that's going to wait for TCP connections and connect via TCP. We're not going to mess around at the TCP level. We're going to use libraries to make our connections. But databases are separate pieces of software running on your machine that connect using TCP. This thing seems so loud still. That connect using TCP. So your web app is going to connect using a TCP connection and then send queries and statements to your database as your app is running. By default, MySQL runs on port 3306, and there's no real reason to change that port unless you want multiple database servers running on the same... This mic's bugging me. Unless you have multiple databases running on the same machine. I don't know what your use case is, but in most cases, 3306, just stick with the default port. In your library of choice, install a library that's going to connect to the database, and then that's how we're going to connect to it. We don't want to mess with opening a TCP connection. Technology is not my friend today. We're not going to mess at the TCP level. We're going to use a library which is going to do the TCP level stuff for us, create the connection, and then we're going to just send statements and queries to our database using that library. So for MySQL connection, you're going to have to specify at least 3 pieces of information. One, the host and port of where the database lives, and then your username and password to log in to the database. MySQL is going to make you set up that username and password. Here I have an example where I'm logging in as root, but you still at least have to set, which root is an account that's set up for you, but you do have to at least set the password. When you download and install MySQL, it will ask you for your username and password. You'll set all that stuff when you set it up. So when you're connecting to the database in your code, you want to make sure you use that same username and password. It's whatever you chose when you set it up. I used to have a few slides on this. I downplay it these days, but never put your passwords. I don't have a mouse presenting like this. Don't put your passwords in your code if that code is being checked into a repository, especially a public repository. A public repository should go without saying. Everybody in the world will have access to your code, to your password. But even if it's a private repo shared just with your dev team, do you trust everybody on that team with a password, depending on what it is? Maybe it's an API key to a service that's going to charge you if it gets too many calls to the API. Just be wary of who has access to your password. Usually we would never do password in code like this. We would store our password in typically an environment variable and then read that variable. But I downplay that these days because I don't want to talk for like 5 minutes about it. Yeah. So your code is going to have to make the connection. So at some point your code has to know that password. The standard answer for this is setting the environment variable of the machine to have the password in an environment variable. Then in your code, you read the environment variable, whatever's stored there, that's what your password is. Now on each machine, you would have a different password. So like in your development environment, you would set your environment variable to some password that you created and don't tell anybody about. And then when you go to production, you go to deploy the app, whoever's deploying to production would set a production password in an environment variable that, ideally they wouldn't tell anybody about, but, minimal people have to know. Some people have to know what that password is. But that's how you would kind of randomize it, is on each machine in each environment, you'd have a different password. And then never check those into a repository. And then whatever library you're using is going to have some way to make that connection. When you establish the connection to the database, that's going to do all the TCP stuff under the hood. So right here, I get this connection, and that connection contains my TCP socket connection and everything else that I need to talk to the database. And I'll give my disclaimer here. I'll give another disclaimer at the end. But I'm not going to go into depth on the databases, on query languages, on how to connect and talk to them. I'll do a little bit, some examples here, but that is a case where I'm going to expect you to go find the documentation for your language of choice and then go through those docs. It'd be too much to go through each language and go through MySQL and MongoDB for each language that anybody might choose. I'm not going to spoon feed you code and examples like that. It's a 300-level course. You're expected to go find the documentation and look that up. That said, we don't do anything too in-depth with databases. We store things in the database in this course. We store things in the database, we retrieve things from the database, we update things in the database, and we delete things from the database. We're not doing joins or anything crazy that you might see in other courses. Like if you're taking a databases course, you'll see all kinds of crazy stuff. I'm not going too in-depth. I'm not asking much use from the databases. So I think I can get away with that. Let me know if you disagree. So once we're connected, once we have that connection established and we have that TCP connection with the database, we start sending it queries and statements. Here, I'm in MySQL, you do have to create tables before inserting data. So I'm creating a table, and I'm going to hit it with this if not exists. So if you're creating your tables on startup, those tables might already exist. If not exists is only going to create the table if it exists. If it already exists and you don't use if not exists, SQL just says I'm crashing. It just breaks. So if not exists, if you're coming up with that error. And then I'm going to say I have two columns, username and points. Username is text, points is int. Self-explanatory. And then when I insert data into this database, the one thing to remember, that again, I assume you've seen this before in at least one other class, always use prepared statements when inserting into your database, into your SQL database. Yeah?
Is this going to create like a CSV file on the hard drive that we can crack into like Google Sheets and read?
Not quite. So it will store data on the hard drive, but it'll store it in the way that MySQL encodes data. So you could use a MySQL, what do we even call it? A front-end service, I guess. Software that's going to read your MySQL database and show it to you, similar to like using Excel to read CSV, but it is a different format. And MySQL is going to, lock down this data. So even that software, you do need your username and password. It is going to protect your data as well. But always use prepared statements in any language, any library I've seen. It always uses this question mark syntax. If you don't see question marks in your SQL queries, you're doing something wrong. You need to have those prepared statements in there. So I'm preparing the statement, insert into players values, and then 2 values, and then I'm setting those values independently. This syntax will be a little different in each language. The question marks will be the same, but how to set those values is a little different in each language. This is Scala, by the way. It's a little bit different in different languages. This is the way Scala does it. It's a little different than what you'll see in Python or JavaScript because this is strongly typed. It needs to know the types of each value. Using prepared statements means that we're going to treat that data as just that, data. So the problem with this, if we're not using prepared statements, it might treat the values as SQL statements, as part of a SQL statement. That's the big worry without using prepared statements. So, for example, if instead of using prepared statements, you just concatenated the values in using string concatenation, and you're taking values from the user, which, have I not said this yet? I'm going to say this a lot, but never trust your users. If you're taking values from your users and concatenating those values right into your query using string concatenation, well, what if the user chooses their username as drop table players, which just deletes your table? You just lost all your data because somebody was writing SQL instead of data that you expected. And even worse, what if they're stealing private information? What if they're able to access your entire database and maybe they want to give themselves, I'm getting feedback getting too close to that thing. What if they want to give themselves admin privileges and then do whatever they want on your server after that? They can do some really bad stuff once they have access to your database, and if you're not using prepared statements, they pretty much have access to your database. Yep.
So even though it's all you need to do to protect against is like 2 or 3 extra lines of code, it's still like the most successful form of attack.
Mm-hmm. Yep. Yeah, so SQL injection is super easy to defend against, and in most languages it's not even extra lines of code. In like Python, you give the prepared statement, and then as a second argument, a list of the values, and they just go in there, which is probably less code than string concatenation in most cases. You know, by characters, maybe characters off. Super easy. The toughest part about prepared statements is just remembering to do it. As long as you remember to do it, you're protected, and that's going to completely, not completely, but almost certainly eliminate these injection attacks, unless. You know, there are still some successful ones with prepared statements. If somebody's really sophisticated, a very sophisticated attacker, might know some attack vector that's really advanced, you know, exploiting some weakness in a library or something. Of course, those are still going to get through, but this is the most common thing. Somebody forgets to prepare their statements, and the database is compromised. Just remember to do it. That's all you got to do. Remember to do it. If you want to retrieve data, you're going to ask the database for data using a select statement. Select, this is going to, star is going to get everything from the player's table, and then you'll have some way in your library to iterate over those values, and then do what you will with those values afterwards. For this class, you know, select star is fine. Select star and then filter after if you don't want to dive into SQL syntax. Yeah, it's whatever. Because I don't want to turn this into a databases class, but we do need to use databases. So SQL is very structured. It's a very similar structure to CSV, where you have rows and columns. Each column represents a certain piece of information, and each row has each one of those columns filled out for its values. Very similar to a CSV file. But what if we want something more complicated than that? What if we want one of the columns to represent a list? So we want multiple values in a single column. Well, we can't really do that in SQL. The real answer, if we're really going to dive into SQL, and if you take a class that really uses SQL in depth, you're going to start using joins, create a separate table for the lists, and then join them based on their foreign keys, primary keys, and all that good stuff. We don't really want to mess with that in this class because we want to stay focused on web apps. But that would be the answer. Or what our answer was in CSE 115 was to go from CSV to JSON, where JSON is a format that can represent a very flexible, very powerful format that can represent pretty much anything. Any piece of data that we want to represent, we can throw it in a JSON string and have very complex structures. This is what MongoDB does. MongoDB, very similar to MySQL in that it's a server that listens for TCP connections. The default port's different, 27017 instead of 3306, but it's going to do the same thing. It's listening on that port for connections, but once you do connect, it's going to speak Mongo instead of SQL, of course. Mongo, if you haven't seen this before, it's really like storing JSON strings. That's very close to how it behaves. It actually stores BSON, it stores things in binary, but it takes the same format as JSON strings. So when we're working in a language that natively supports JSON formats like Python and JavaScript, which is why those are the two most popular languages in the course, one of the reasons, is we just throw these things in the database. We have a JSON string, which would be, or an object in JavaScript or a dictionary in Python. We just throw it in the database. That's it. Done. Just throw it in the database. So this is what Mongo gives us, is we can store anything that we can represent in a JSON structure in the database. And we can throw them in there directly. We still need to connect to the database. We're going to connect to the host. So we're still specifying the host when we connect. But by default, MongoDB doesn't require a username and password. Just by default, it's going to block out any outside connections. And MongoDB has the assumption that if you have access to the machine, that you have permission to use the database. You can set up a username and password as an additional precaution. But by default, MongoDB is just like, nah, I ain't going to allow outside connections. That's silly. Or MySQL, by default, is going to allow outside connections and sets up the username and password. So just different ideas. But this is one of the things that just makes MongoDB easier to set up and get going, especially for a course like this, where you don't want to be messing around with all kinds of configuration. Just give it the host and you're connected. Yeah.
Would that be the host or is there 0.0 required?
This, for now, localhost. We're actually going to change that by the end of the lecture, but it won't be 0000. So you want to connect to the host. If you're downloading and installing your database, which I recommend, you'll want to connect to localhost if it's running on your machine. I do recommend that. By the end of this lecture, we're going to be running our database in Docker using Docker Compose. But I recommend also setting up a local instance of your database because it makes debug cycles a lot shorter. You don't have to spin up Docker every single time you want to debug. You just run your app and connect to the database. So I do recommend, if you're going to use MongoDB or MySQL, go to the website, download the software, install it on your machine, set it all up. It makes it a lot easier to debug instead of always working in Docker. And then work in Docker when you're ready to submit to Autolab. Do your final testing, debug any issues that Docker might not have synced up with, and then submit. Yeah, question?
Wait, how do you make it so if there's a way of making Docker Compose up, like automatically update the files if you updated if you like change the code, right? Mm-hmm. So you don't have to like delete it all and then restart entirely? Right. How do you do that? Do you have to like name it or something?
You do, my last slide will show the command off the top of my head. I think it's Docker Compose up --build --force recreate. Force recreate.
Right.
That'll tear it down, delete everything, recreate the image, and then create a new containers based on the new images, and then run them.
Right.
That'll do everything in one nice command. But it takes a while. That's part of your debug cycle. It takes a little bit. You punch in that command, and it just takes a bit to spin up.
It's rather like swap.
But yeah. If you're just doing like Python 3, run the thing again, it's just a lot quicker. It's more almost instantaneous for a debug cycle. Because Docker's recreating the images. The big slowdown is re-downloading your dependencies. Is to download those again. Once you're connected to a MongoDB database, there are a few levels to be concerned with. Is the database and collections. So databases, MongoDB, the server is going to have many databases potentially. If you only want one, obviously you're only going to create one. But it can have multiple databases. So you'll connect to the database you want, and then connect to the collection you want, where collections are like the SQL tables. That's where your data is actually going to be stored. So you have your server with databases with collections. Collections is where your actual data is going to be stored. One nice thing, so in MySQL we had to say, create this table if it doesn't exist, all that. In MongoDB, I'm just going to say, give me the database name CSE 312. And what Mongo's going to do is say, either here you go, here's your database, or it's going to say, oh crap, there's no database name CSE 312. Hold on, let me just create that for you real quick, and then give it to you. So it just creates it if it doesn't exist. Same with the collection. Oh, I don't have a collection named chat in the CSE 312 database. Let me just create that right quick for you, and then give it to you. So it's going to create these things just by demanding a string like this. It's going to create it if it doesn't exist. So another just quality of life thing that Mongo's set up to do for us automatically. And part of that is because it's unstructured. Like SQL, you have to create the table because you have to specify all the columns and their column names and their types. But MongoDB, you just create a collection and you can store any format in that collection. So it doesn't really have to think that hard about it. Oh, you want a collection with that name? Yeah, let me create that for you. Inserting into the database, or into a collection. You insert into a collection and retrieve from a collection. Just give it something in a JSON format. Python, JavaScript, this is just straight up object or dictionary. This is Python. I'm going to give it a dictionary. And now that dictionary is stored in my collection. That's it. Okay.
Like this data is growing, redundant, like the MongoDB will still store like redundant data.
Yeah, like if I ran this line of code twice, I'm going to have two documents in my collection with the same data. It won't do any redundancy checks. And you can mix formats. If I want to store this JSON string and then I want another JSON string with different keys, different values, different types, I'm free to do that. Yeah.
Insert or just like insert and retrieve?
There's update. I don't have a slide on it in this slide deck, but you would say that update. Oh, I meant to update this slide actually too. That should say insert_1. The insert method they got rid of because why would we have a nice, conveniently named method called insert? You would do update and then give it a query and then the values you want to update. Update the values. It is, with quite a few things in this course, W3 Schools does have good tutorials on these. It just runs down the different operations in a nice, succinct way. But I probably should have added a slide for update, but I don't want to just keep going through every feature of the databases. Yeah.
Is the reason why there's no injection attacks because it doesn't just store strings?
Yes. Yes. So with MongoDB, we don't have to worry about the prepared statements either. MongoDB has us covered on that front as well. So the way SQL works is you say, hey, SQL database, here's a string, run it. And it's hard for MySQL to determine the difference between SQL code and data that's being stored in the database. So it has to parse through this and say, okay, insert, that looks like SQL, and then go through it. But it's just doing string parsing to figure that out. So it's hard for SQL to define those boundaries between data and SQL statements, like SQL commands and stuff. That's why we need to use prepared statements to say, this is data, this is a SQL, this is part of the SQL statement. With MongoDB, we don't have that issue because we're storing documents. The structure of the data itself is going to determine the structure. And then all the data is just data. Like there's nothing to, what am I trying to say? There's nothing to interpret here. The database looks at this and it's very clear that there are keys and there are values. There's no, if somebody's typing hello into the chat, like there's nothing they can type there that's going to be executed as a Mongo statement because it's just straight up going to be a string. If they add, braces and stuff in there, it's just going to be interpreted as string. Just straight up, it's just a string. It's not going to be parsed. There's no parsing here. It's just going to be interpreted as a string. So we don't have that same issue. There are some libraries that were dumb and had vulnerabilities, specifically a PHP library had vulnerabilities, but Mongo itself does not have that issue. The library was interpreting strings and then building the MongoDB queries based on the strings, and that's not what the library should be doing. MongoDB doesn't have these SQL injection problems, at least not in the same way that MySQL does, or any SQL language does. SQL database does. SQL database server, let me get there. And then to find things, we have .find or .find_1. Find is going to take a JSON formatted string, in this case a Python dictionary, not string, but JSON object. It's going to take a JSON object and return every document with those values at those keys. So it's going to give me every document with a key named username that has a value Hartloff. So it'll give me every document in the database matching that query. If I want absolutely everything, so if I want the equivalent of select star, just give it an empty dictionary, or empty JSON object dictionary in this example. And that's going to return everything that matches that query. Well, that query isn't checking anything, so it's just going to return everything. So as a quick summary, MongoDB, very unstructured. You just dump data in the collections, and that's it. This can sound nice. You get a lot of flexibility, but you also have no guarantee about your data. You don't know anything about your data that's in the database. It's up to you to enforce any structure in MongoDB, because MongoDB isn't made to enforce any structure at all. It's just going to let you do whatever you want. SQL is very structured, but the advantage of SQL is that it's fast. You set up that structure, and SQL can take advantage of that structure to do some really nice things like indexing, and get a lot of efficiency out of your data and give you really fast operations. So my hot take on the comparison of these two, or any NoSQL database versus SQL database. MongoDB, it's really good for prototyping when you don't know the structure of your data. Your app is in its infancy. You're going to constantly be adding fields and changing the structured data, where if you have a SQL database, you might be updating tables, creating new tables, and all this stuff. That's where MongoDB, in my opinion, really shines, is when you don't know the structure of your data. Once your app starts settling down, it starts getting into maturity where you know the structure of your data and you know what data you're going to be working with for the foreseeable future. That's when you want to use SQL. That's where SQL shines. Take advantage of that efficiency, get that speed, get that optimization that SQL offers. Any reasonably mature project should be using SQL, or not necessarily SQL, but some structured database. But when prototyping, go ahead and use your MongoDB and your unstructured databases. Which, for this course, I would consider all of your homeworks and projects to be under the prototyping stage, because things are constantly changing. Plus, you don't have millions of records where you need SQL, where you need structure. So you are expected to find some documentation, whatever language you choose, figure out how to get that connection library and how to connect. I showed Scala examples for MySQL. I showed Python examples for MongoDB. So I did make sure that I got my recommended Python and MongoDB. I made sure I got some examples of that one in there. But I'm not going to go through every single language. If you're using Postgres with Java, I had to draw the line somewhere. But I got the recommendation, some examples in there. So what we're actually going to do, instead of downloading these, installing these, which I recommend you do for testing, is we're going to use Docker to be able to create these things. Specifically Docker Compose. So what we want is a separate container that's going to run our database. So we're going to run our database in one container, and we're going to run our app in a separate container. Because even if we're not using Docker, our app is one process and our database is another process, and they're going to speak using TCP. With Docker, we're going to create them both in separate containers and still have them speak using TCP, but they're going to be in different containers. So once we need multiple containers, this is where Docker Compose comes in. Docker Compose is going to give us a handy way to create multiple containers that are both supporting the same app. So we're going to create what's called a docker compose.yaml file. Docker, all lowercase letters, -compose.yml. And Docker Compose is going to look for a file specifically named this, Docker Compose YAML. So let's take a look at this file. This one's going to create my app and my database using an existing Docker file for my app, like the one we created last time, which we're going to modify a little bit, but not too much. So let's go through this thing. First, you're going to have to specify the version of Docker Compose that we're using, the version for the format of the file that we're using. I have 3.3 because that's what was cool when I first started using Docker Compose. They're up to 3.8 right now, so if you want to use any of the later features, be my guest, knock yourself out. 3.3 will do everything that I'll show you in lecture, though. But you do have to specify the version. There are certain features that if you're not using the right version number, they won't be compatible. And then I'm going to specify my services. If you haven't seen YAML before, by the way, this is YAML format. It's similar to JSON, but it uses indentation as kind of the way Python uses indentation. So I'm going to create services, and then everything indented is going to be under the services object. And then Mongo and app are two different services, with everything indented being part of each one of those. So just a different format. JSON won the battle when it comes to the web. JSON was the one that was widely adapted for the web and communicating data over the web. YAML, for some reason, seems to be preferred when setting up configuration files, which I agree, it's easier to read. I can see why. But YAML, when you have configuration files, is typically the preferred format. Not all the time, but a lot of places, a lot of developers prefer YAML. So services, each service that I create is going to be a separate Docker container. So I'm going to create two services, Mongo and app. And these services will be able to communicate with each other. But whatever I name them in this file, that's going to be their host name. So when one of these wants to connect and talk to the other one, I have to use the host name that I give it here. So this is where we're going to change how we connect to our database. In this case, instead of saying Mongo client of localhost, I'm going to say Mongo client of Mongo, because that's going to be the host when I'm running inside these containers using Docker Compose. So no longer localhost. So this is one thing where if you have a local version of your database and one that you're going to use in Docker, that's one line of code that you have to change each time you switch environments. If you're using your local running instance of your database or one inside Docker Compose, change the host name. One's localhost, which would be local to inside that container. If you want to access something outside that container, use the host name that you named it here. Those names are whatever you want to call it. I just happen to name them app and Mongo. I think those are pretty straightforward names. I want to keep my names nice and simple. But you can name them whatever you want. There's nothing special about the names I gave them here. My Mongo container, I don't have a Docker file for that one. So I'm going to specify the image that I want here, which is the same as saying having a one-line Docker file that just says from MongoDB. So I'm going to create a container that's just a raw image with no modifications. So I'm going to take the Mongo 4.2.5. Again, if you want to use a different version of Mongo, You don't have to use the exact version that I use here. When building the app, I'm going to specify the Docker file that I want to use. Specifically, I'm going to specify the directory where the Docker file lives. This is the same as that trailing dot when we built images in the last lecture. I'm going to say dot, hey build, dot, look in the current directory, the same directory as the Docker Compose file, find a Docker file in there, and use that to create this image. So it's going to create that image, and then I'm going to have to specify any of the things that we did in the command line when we built an image, specifically mapping the ports. But we also have this extra thing now that we're working with a database that we have to think of. And this completely replaces building the way we did last time. We're going to build with Docker Compose to build multiple containers simultaneously instead of one at a time. So we got to specify everything we did last time. Yeah.
What if you already declared the ports in the Docker file?
We still need, so this is the same, let me jump ahead to that one actually. So this is the same as our -p when we built when we ran the container. This is the same as that. We're mapping 8080 locally on our machine to 8000 inside the container. So it's the same thing that we did last time, but now that we're not building one container at a time like we did last time, we need a way to get that information in our Docker Compose file. So this is the same thing as that -p that we did last time.
What's the dash format?
It's just the format
Okay.
Of the file. And we have this extra thing. So this is brand new. We're going to update our Docker file. In addition to this, is we have this really big issue. We have a database. When we run our database, we're going to create a brand new image, a brand new container, and spin up our database. MongoDB in this case. And we're going to say, MongoDB, go do your thing. MongoDB is going to be a TCP server. It's going to contain a TCP server that's listening for TCP connections. The problem is that takes a little bit to start up. If you just start up a MongoDB server, it's going to take a bit of time to do all of its initialization, all of its setup, all of its startup, before it gets to the point where it's willing to accept a TCP connection. When we run Docker Compose, we're creating both of these containers at the same time, one for our database and one for our app. One of the first things your app is probably going to do is want to connect to the database. So if these are running at the same time, what happens when your app tries to connect to the database that's still running its startup script and not accepting TCP connections yet? That's where we get issues and you get bugs that are really frustrating. It's a tough bug to, if you don't know what you're looking for, it's a tough bug to find. Here's my solution. Feel free to use whatever solution you want. I'm not aware of somebody who's found a different solution than this. Maybe they had. Actually, I think somebody. Anyway, this is the one that I'm pitching. If you want to use something else, go for it. But this is what I like to use. So I'm going to set an environment variable. This is the same as saying env in our Docker file. I'm going to set an environment variable for wait hosts, which is going to be read by some software. I'm going to add a few lines to my Docker file. It's going to be read by software that's going to read that environment variable and wait until that connection is listening for TCP connections. That host port pair is listening for TCP connections, accepting TCP connections, and then it's going to exit. And then when I run my app, I'm not just running my app, I'm going to run this wait command that I've downloaded, and then run my app. So now I'm going to run wait. Wait is going to say, hey, Mongo 27017, are you accepting TCP connections? No, you're not? Okay, let me just chill out for a little bit. Hey, are you accepting connections now? Are you accepting connections now? Accepting connections now? And as soon as MongoDB says, okay, I'm ready for TCP connections, then wait exits, and then my Python app.py is going to run. Now when I run my app, I know that my database is running. I know that it's good to go. It's ready for TCP connections. My app, as soon as it starts up, can connect to that database knowing that it's accepting TCP connections. This solution, shout out to GitHub user UFO Scout. I have no idea who it is, but I use their solution in lectures, so I got to shout them out. The first line, this add, is going to download the command which they're hosting on GitHub for free for us all to use. And then the second line changes the permissions to make sure that I can execute that command. And then the command, I'm going to execute that. Yeah.
Should we cite them, or is it okay if we just use it because you showed it?
No, you can just use it for this.
Okay.
They have it available open source. They actually have a pull request to add this feature into Docker Compose. As far as I know, it hasn't been accepted yet. But I'd like for this feature to just be part of Docker Compose, but maybe someday. But until then, we'll just do this. But very important to have this. And Mongo 27017, that Mongo has to match the name of the service. I'm using that as a host name, which is the name of the service. So if I name my service something else, instead of Mongo, I said MongoDB, I would have to change that to MongoDB in my wait host as well. God, it's 344. Ports we already talked about. And remember, I already mentioned this, but remember, update your connection to your database to whatever you named it in Docker Compose. Oh, come on. Why would you exit automatically? And then a few commands. Once you have your Docker Compose set up, Docker Compose up, and that's it. No Docker build -t image name dot, and then Docker run -p, all that. Docker Compose up, and your Docker Compose file has all the information it needs to run everything. If you want to run in detached mode, same as running containers, -d at the end. And to restart your container and rebuild everything, Docker Compose up, build, force, recreate. That's going to go wipe everything away. It will delete all of your data in your database as well. And rebuild from the Docker Compose file and the Docker file. Rebuild everything and then restart your database and your app. If you want to restart without rebuilding, which we do in the testing procedures, Docker Compose restart. That's just going to restart your apps. It's going to wipe all memory, but it's going to preserve everything in your database. Yeah.
Doing Docker Compose restart will not update with any code changes.
Correct. Yeah, if you do restart, it doesn't get any code changes. You want to do the build, force, recreate if you've changed any code.
Does that go in the command prompt?
Yes. Which is the next thing. We can do this. So I have this example. This is the Python app, the same code that I showed last time. I just added the connection to Mongo. And I'm going to insert into a collection, just inserting some data into my database, the client ID in this case. My Docker Compose file, just as we saw it in the slides. My Docker file. And the one thing I didn't mention yet is we do need external libraries now. So now we are using that requirements.txt or package.json if you're using JavaScript. I'm going to install all the requirements in requirements.txt. And I'm going to list my requirements, which is just PyMongo for this example. I'm going to use PyMongo to connect to my Mongo database. And then when I go into my command line, which I have it already running, oops. You don't stop, I'm going to force you. Right. And then Docker Compose up, build, force, recreate. It's going to start up my app. And we can see the app, it's listening now. I'm not going to go through that because I don't have a ton of time. Refresh, we should say hello. And then 3 minutes. Yeah, let's do this. So if I do Docker PS in the command line, I could do this in my other command line inside VS Code as well. I'm going to do it right here because I already have this open. I'm going to grab the container ID. I'm going to do Docker exec-it, the container ID, and then bin bash. This is going to enter the container. I'm entering my database container here. And just real quick, I can do some command line Mongo. I don't have a ton of time to explain, so I can explain this in a different lecture when we have time. But db.logs.find everything, and I can verify that I do actually have those client IDs stored in my database. So I can go in my database, look around, and see what's there. Right, but we don't have, we only got 2 minutes. I want to give you, I had a bad habit last semester of showing a lecture question like right at 50 on the hour. So I want to make sure I stop doing that. So did with 48 on the clock. I'm okay with that. And have a great day.